All right, so in this lesson, we're going to go over how we integrate logarithmic functions. So let's remember first that integration is, the opposite or the inverse of differentiation. So, we learned in the lesson before that the derivative of the natural log of the absolute value of x is 1 over x. And then so that means if you're going to integrate 1 over x, you're going to end up back with the natural log of x plus, of course, your constant c. So we're going to use this, equation for integrating logarithm functions. And of course, when you have like, a composite function, if you have, something that's more complicated than x, we can use U substitution, and we're going to use the chain rule. So let's go through some examples. That's going to be the best way, obviously, to get good at this stuff. All right, so first we got integrate 2 over x dx. Okay, so first let's recognize that this is simply just same as 2 times the integral of 1 over x dx. You can just factor out that 2. So all you're really integrating is 1 over x. And the definition is that the integral of 1 over x is equal to the natural log of the absolute value of x plus c, of course. So then this will be 2 times the natural log of the absolute value of x plus c. Right now for 2, we have the integral of 1 over 4x plus, or 1 over 4x minus 1 dx. So here we're going to use U substitution. So what we're going to do is we're going to make the U the 4x minus 1. And then du will be 4 dx. Now we don't have 4 dx, we just got 1 dx, so we're going to divide this by 4, so we're going to have 1/4 du equals dx. And then we're going to go from here. So we're going to rewrite this now as 1/4 times 1 over u du. Because, remember essentially we got 1 over u down there. That's our u. And you have the 1/4 du as a dx. So, it may be a little weird to look at it like this, but this is essentially what we have. 1/4 dx. 1 over u times 1/4 dx. And we can factor out this 1/4, so it doesn't become an issue. Times 1/4 times the integral of 1 over u dx, or whoa, that should not be a dx, it should be du. Of course, that's what I meant. Fix that. There we go. So 1/4 times the integral of 1 over u du. And then from here, we can just use the integral of 1 over u definition. So this will be 1/4 times the natural log of the absolute value of u plus your constant c. And we replace u back with 4x minus 1. We're going to have 1/4 times the natural log of 4x minus 1 plus c. And remember, you can always check your answer when you get an integral, because the derivative, if you differentiate this, you should end up back with this. So always, if you're wondering or worried that you didn't get the right answer, go back and check, just differentiate it and make sure you get the right thing. All right, let's look at a couple more. So here next we got the integral of 3x squared plus 1 over x cubed plus x. Okay, so some more u substitution actions. We're gonna make the u equal to the 3x squared plus 1. Oh no, sorry, we're gonna make the u actually the x cubed plus x, because the derivative of this, you can see, is gonna end up being 3x squared plus 1. So we're gonna make u x cubed plus x. Du will be 3x squared plus 1 dx. And right away we got that. So we can rewrite this integral as simply 1 over u du. And then we can integrate this. That's the definition. As we've been doing, it will be the natural log of the absolute value of u plus your constant c. You can go back and then replace u with x cubed plus x. Get the natural log of the absolute value of x cubed plus x plus c. That's your answer. All right, 4, we got some trig action now. Secant squared of x over the tangent of x dx as our integral. So let's remember that the derivative of the tangent of x is the secant squared of x. So we're going to make the u the tangent of x. And du will be secant squared of x dx. And we straight up have that right in our integral. So we're going to rewrite the integral as simply 1 over u du. Du is just what we got up here. And then again, we just integrate this with the definition of the natural log of the absolute value of u plus c. And again, replace that u with the tangent of x. The natural log of the absolute value of the tangent of x plus c. And there's your answer. Yeah, don't get freaked out. You're taking the natural log of a trig function. Sometimes students double guess themselves when they get an answer like this because they don't like they find this kind of weird. All right, let's get 5 now. All right, 5, we got x plus 1 over x squared plus 2x dx. We're going to make the u the x squared plus 2x. And du will be 2x dx. No, that is not what the u needs to be. 2x plus 2 dx. Sorry, I meant to say. X plus 2 dx. Okay, then we kind of almost have that. So we have 1x plus 1. So 2x plus 2. So we just have to divide this by 2. And so then we end up getting that 1/2 du will be your x plus 2. Or will be your x plus 1 dx. So now we can rewrite our integral with the, with this whole part as our 1/2 du. And then this will be u. So our integral becomes 1/2 du. I mean, I'm going to write it literally what it looks like in case you're wondering how this works. If you caught on, you don't feel you have to write it like this if you got caught on. It all works out. 1/2 times du over u. This is going to be the same as 1/2 times the integral of 1 over u du. So it again works out nicely. So then we just replace, or we just integrate this 1/2 times the natural log of the absolute value of u plus c. Replace u back with the x squared plus 2x. So you get 1/2 times the natural log of the absolute value of x squared plus 2x. Space. Plus c. Here we go. All right, so let's go through this last one for now. We got the integral of 1 over 3x plus 2 dx. Here we're going to make the u the 3x plus 2. Then du will be 3 dx. We don't got 3 dx, but we got 1 dx. To divide each of these by 3. So we'll get 1/3 du equals dx. And then we can now write this as the integral of 1/3 du over u. So again, you can look at it like literally like 1/3 on top times du over u. Remember, it's all being multiplied, and then again you can factor. Go down over here. You can take out that 1/3 coefficient, so you have 1/3 times the integral of 1 over u du. And then we just integrate again. This becomes 1/3 times the natural log of the absolute value of u plus c. Place the u back with our 3x plus 2. We get 1/3 times the natural log of the absolute value of 3x plus 2 plus c. All right, there you go. So good luck.